This is the first Vodcast for your Chapter 17 and 18 notes. We'll be talking about electric forces, electric fields, electrical energy, and capacitance. We'll start with Section 17.1, electric charge, and we'll be looking at properties of electric charge and properties of the atom. We'll start with 5 properties of electric charge, and the first one is that like charges repel. The types of charges that we'll be dealing with are positive and negative. So 2 positive charges will repel and 2 negative charges will repel. Conversely, opposite charges attract. Next, an object is charged by the transfer of electrons. So if I take a balloon and I rub it on my hair and then I can stick it to the wall, what I've done is I've transferred electrons between the balloon and my hair. And that creates a net charge on both objects. Point 3, electric charge is always conserved. What does that mean? Well, point 3 goes with point 2. Conservation of charge means the charge is neither created nor destroyed, it is transferred. Charge can be transferred between objects. Point number 4, the electric charge is quantized. What does this mean? Well, this really goes with point number 5, which is that an electron has a charge of 1.6 times 10 to the negative 19th coulombs. You cannot have a charge less than that. The least amount of charge that you can have is equal to the charge on 1 electron. And then you can have 2 electrons worth of charge, 3 electrons, 4 electrons, and so forth. So when I say that it's quantized, what I mean is that it comes in discrete quantities or multiples of the charge on 1 electron. The atom. Electrons are the negatively charged particles that are part of an atom. They're located on the outside of the nucleus, and they move around the nucleus. Electrons are involved in bonds. Electrons can be transferred from one atom to another. You can see from my description here that we are not getting as detailed as you would in a chemistry class. We want you to understand that electrons can be transferred, and that electron transfer is what creates net charge. 1 electron has a charge of negative 1.6 times 10 to the negative 19th coulombs. 1 electron has a mass of 9.109 times 10 to the negative 31st kilograms. Both of these pieces of information will be given to you on the green sheet on the AP test. So you do not have to memorize them. However, you will need those pieces of information to solve many story problems. Protons are positively charged particles that are part of an atom. They're located in the nucleus. They have the same magnitude of charge as electrons. However, they're much more massive than electrons. 1 proton has a mass of 1.672 times 10 to the negative 27th kilograms. Again, these 2 values are given to you on the green sheet. Finally, neutrons are neutral particles located in the center of the atom, in the nucleus. And just a reminder that breaking apart the nucleus is very difficult and releases a lot of energy. And we're not going to be talking about atomic fusion or fission here. What we are going to be talking about is what happens when electrons transfer between atoms. Net charge. Because of quantization, we can determine the exact charge based on the difference between positive and negative charges. Here's what I mean by net charge. It means the sum. If I have 5 negative charges and 5 positive charges, the net charge is 0. The unit for charge is the coulomb. And the variable for charge is Q. So it gets a little confusing because charge, Q, is measured in coulombs, C. Let's take a look at the next. We have 3 negative charges and 5 positive charges, giving us a net charge of 2 positive charges. Now, if I wanted to determine the exact amount of charge, I would take 2 times the charge on a proton, which gives me 3.2 times 10 to the negative 19th coulombs. Finally, for my third example, I have a net charge of -1, which would be equivalent to the charge on 1 electron, which is -1.6 times 10 to the negative 19th coulombs. Let's talk about insulators and conductors. Conductors are substances that allow charges to freely move in response to an electric force within a conductor. Insulators do not allow charges to freely move. We're not going to talk about the specifics of exactly why. We're just going to say that when we're working in a conductor, the charges can move. And metals are good conductors. So here, I'm going to show you an example of charging by conduction. And charging by conduction is the same as charging by touching 2 objects together. And in this example, I'm starting with a neutral conductor. A neutral metal rod. And remember that neutral doesn't mean no charge. Neutral means an equal number of positive and negative charges. Then what I'm going to do is I'm going to bring an object with a net charge near my neutral conductor. So this is going to be an insulated rod, like a plastic rod. And what happens? Well, the electrons are attracted to, and the electrons can move. So the electrons are attracted to that insulator, and if the insulator touches the conductor, the electrons will actually transfer to the insulator. And what happens when the electrons transfer is they actually leave which leaves me with a net positive charge. There are 2 other situations I'd like you to know about. The first one is called charge separation. Charge separation is the same thing as polarization. And we're going to look at it on the left here. Again, I'm starting out with a neutral metal rod. And remember that neutral just means that there are equal numbers of positive and negative charges. And then what I do is I bring an insulator. Here's my insulator with a net positive charge, and it causes the charges in the neutral metal rod to separate. Now this is a little bit misleading because the positives can't really move. The nuclei cannot really move around. So it would be more realistic to say that these negative charges travel, in this case, to the left. They're going to be attracted. I think it would be more realistic to say that the positives are still evenly distributed throughout the rod. In my next example, we have charging by induction. And in charging by induction, the object is left with the opposite charge as the object doing the charging. What I do in charging by induction is I start out again with my neutral conductor, And in this case, it's actually a neutral grounded conductor. That is, it's hooked up to ground. Now I'm going to bring an insulator. In this case, my insulator has a net negative charge. And I bring it near my conductor. And what happens is that the electrons in the conductor are repelled. And so they travel, they want to get as far away from these electrons as they possibly can. And so they travel through the ground wire to ground, leaving me with a net positive charge.